Hello, everyone. Tonight I wanted to actually do an overview of machine learning, and I'm going to particularly use Amazon to do my demonstration. I've been doing a lot of this over the last couple days as part of some research that I'm doing for work, but I'm also, very interested in learning this, just for my own, fun and excitement because I love technology. Um, and I found that Amazon makes it really super easy to get into machine learning, and I'd like to, kind of demonstrate that. And I'll go over some machine learning terminology as we go. Let's get started. So there are kind of two basic ways you can get started. You can just jump right in and start making a model and all that kind of stuff, or you can go to this dashboard and then kind of build stuff the way you want. I'm gonna jump into the simple standard setup. And basically, the first thing you do with Amazon machine learning is that you pick your data source. And usually, you can pick one. Obviously, you can see that you pick one of two data sources. You can pull files from S3, or you can pull from Amazon Redshift, which is basically like a database. So you set up a database, you put data into it, and then you can use that that data source. But I'm going to actually use some files from S3, and I have a couple of buckets that are sending out in S3. I have a ML demo data bucket that I put my source data into, and then there's this other one which has some bulk predictions that I did with machine models earlier. I'll get into that stuff later, but basically, what I do is I go out and I'm actually gonna pick this one here. Um, this data here it's some very simple data that let me pull it up in Excel. And so it's basically something like this, where you basically have a sex, you have an age, which I believe is in months, you have a height, and then you have a weight, which I believe is in kilograms, and the height's in centimeters. So basically what we're doing is, based on your sex and your age and your height, we want to predict your weight. And this is the sample training data that is provided. So I'm going to basically feed that training data in. So click verify. Great. Then basically it says, okay, we determined that it's a common separate value. We, kind of auto-generated a schema source, or you can actually provide your own schema source if you would like. But so, and we jump into this, and actually one of the first things is that the first row of the actual training data is a header row. So it asks you, does it contain column names, which it does. So I say yes, and it kind of regenerates my schema and says, okay, great. These are the different column names. These are the different column name types, and that gives you kind of some sample values, that are in those fields. So right, that looks all good to me. Then basically what we'd have to do is pick which of these is the target, which in this case is the weight. So we say continue, and then it asks us, does our data contain an identifier, which would just be like an index, or a primary key, right? Are the rows numbered? Ours does not, so we're just gonna go ahead and skip that. All right. So we got the input data, which was the CSV file. It's approximately 2.7K. So it generated a schema for us from that input data, and then it figured out that the target is weight, and then there was no row identifier. Great, looks good so far. Then now what it's going to do is generate what's called a regression model, which is fine, because essentially what we're trying to do is we're trying to calculate a weight, which is a um, it's just a numeric value, and there's basically a couple of different types of models. There's a multi-class, which basically means if we're trying to put things into one or more buckets. So a good example would be, say we're trying to predict which movie is going to win next year's Oscars, right? So there's going to be a certain number of possible options that it's going to predict against, right? You can only probably only gonna be like 10 movies that are gonna fall into possible, and then you feed in a whole bunch of different things like who directed it, who produced it, who's in it, things like that, and then it falls in, you're gonna get certain amount of, things that are going to lead to one movie versus another getting. So anyway, that's a multi-class, and then there's usually a binary, which is you're trying to predict something is true or not. So for example, you want to predict is an email a spam or not. So you have the binary, you have the multi-class, and then you have regression, which is just basically you're trying to predict some numerical value. it's in a particular range. And our value, of course, is the weight. So you can basically pick a default recipe. So Amazon takes care of everything. It kind of figures out the best algorithm for you. It will split up the data that you put in as a seed into 70% to train the model, and then 30% to do an evaluation of the model. I'm not going to go into heavy detail about what training a model actually means. There's plenty of good sources on that, but the idea basically is that if you scatter a whole bunch of points on a graph, and you're trying to find some kind of correlation to why do they end up in certain spots, right? So you're basically building an equation that, given the inputs, produces a certain output, and then there's basically some statistical methods by which you can kind of you can assign weights to the various inputs that will then generate the output, sort of. So kind of a rough way of describing machine learning, but that's kind of what it's about. So then you do one last review. So we have a data source that got created, we have a model that got created, we chose the default recipe settings, and then we have some advanced settings like the maximum size of our model, which is not a big deal, except that they do charge you for storing the model. So, but whatever, our model's not going to be very big. How many passes over the data we're going to do, whether or not it shuffles the training data, which is fine. It's just to basically it's going to split up. It's going to basically break off and try and create several copies of the model with different settings, and kind of evaluate which one basically produces the best result, and then pick that one. And then there's the regularization type, and there's two types, L1 and L2. I'm not going to go into the details on that, but basically what these two methods do is to try and make it so that the model that is generated is not just memorizing the sample data that you passed in, so that when you go and you feed it new data, that it doesn't perform as well, because it was so overfitted to the training data that it isn't really generalizing to what's really going on. So regularization is a way to kind of keep the model honest, so that it isn't fitting too closely to just the training data and not a general model of it. So all right, so we create the model. And then, okay, so it goes, and then basically what it's going to do now is it's going to sit and it's going to do all that training that I was talking about. And this actually takes a few minutes. I'm not going to make you wait, for that. I will probably, actually, in fact, come back and do a second model or a second video on this when this is done. But basically, it's going to generate this model, and then it's going to do some valuations on it, and then it's going to be able to tell us, how it scores. And then once we've actually our model is done, it's created, it's evaluated, then we can actually do some real-time predictions on it. So you can literally just put in data, and we could put in an age and a sex and a height, and then we will click a button, and we would get a prediction on what the weight would be directly out of it. And then also they allow you to create an endpoint so that you can basically hit it from the outside world. So that's basically all there really is to Amazon machine learning. I'm gonna put a second video out to go over doing the actual evaluation and prediction part once this is all done. So look for that. Definitely subscribe. Give me feedback. Thank you very much.